Well, we now come to gold leaf electroscope and grounding. To begin with gold leaf electroscope, a gold leaf electroscope is a device which is used to detect the charge on a body, for which we have a very simple apparatus where we first consider an evacuated chamber in the form of a glass window. Into this glass window, we would have a conductor which is passed through it, where you all can see on this conductor there is a metal knob which comes in contact with the charged body. This metal knob is further connected with the help of a metal rod which passes through the evacuated chamber, and we have a insulated stopper which is between the conductor and the glass slab so that the material or the conductor can pass through it very easily. This conductor is further connected to gold leaves which produce the amount of divergence or the convergence that has to be recorded. Hence, a gold leaf electroscope works on the principle saying that like charges repel each other. Let us assume that conductor with the metal knob which is shown into that in the form of a sphere with the gold leaves. And now if I bring a charged body, a negatively charged body, very close to the conductor and place it in contact, it is seen that as conductors allow the movement of charges on their surfaces, all the negative charges move along the surface. Hence, the gold leaves now tend to repel each other and move away, hence showing some amount of divergence. Similarly, if I consider the same device and now place a positively charged body in contact with that metal knob, all the positive charges are again moved along the surface of the conductor, and the gold leaves again tend to repel due to like charges repel each other. Hence, we can come to a conclusion saying that the amount of divergence depends on the amount of charge given to the electroscope. So more the number of charges given, more is the amount of divergence. Further, let us assume that this negatively charged body now, or the charges that were given, are now brought in contact with a positively charged body. Immediately, all the negative charges are transferred to the positively charged body, and hence the gold leaf tend to move towards each other, showing some amount of convergence. And similarly, if this positively charged conductor now is placed in contact with a negatively charged body, all the positive charges move towards a negatively charged body, or we can say this body starts acting as a neutral body where all the negative charges, once transferred, will have some amount of convergence seen on the gold leaf. Hence, we can again conclude saying the amount of convergence on those gold leaves depends on the amount of charge given to the electroscope. Further, we are coming to the next concept which is known as grounding or earthing. Grounding is a process of sharing extra charges or excess charges to the ground. So whenever we're talking about grounding or into diagrams, grounding is represented by the symbol as shown. Let us assume we have a conductor which is negatively charged. And if suppose I connect one end of this conductor to the ground, immediately all the negative charges which are there on the surface of the conductor will move towards the ground, because ground, or you can say earth, is assumed to be a body which can have or can accept n number of charges. Similarly, let us assume that I have a positively charged conductor, and if this positively charged conductor now is connected to the ground or is been grounded, all the positive charges on the surface of this body will move towards the ground. Hence, excess charges or extra charges that are there on the surface of a conductor can be easily transferred to the ground. Similarly, if there is a positively charged body and this positively charged body is connected to the ground, to bring this charged body to a neutral body, charges from the ground can be easily transferred to the body to make it a neutral body, as shown in this slide. Let us assume that there is a person who accidentally puts his finger into a socket which is seen at homes or into any workplaces. If accidentally a person puts his finger inside that, what happens is he is bound to get a shock over there. Reason is, as soon as his hand is placed inside that, as soon as a human comes in contact with an electric terminus, the charges from that electrical terminus start flowing through his body towards the ground. In that case, the person is bound to get a shock. Hence, he completes the circuit by providing a path for those electrons or the charges to flow from the terminal to the ground. To prevent this, it is preferred a person can wear an insulator in the form of a rubber, that is slippers, or can use wood under his feet so that the charges do not touch the ground. Hence, an insulator can prevent these charges from flowing from the terminus to the body. Hence, grounding. And here we show an electric socket where you'll have one terminal represented as a phase, the other terminal represented as neutral, and the third terminal which is represented as a ground. It is this part of that socket where extra charges or excess charges tend to flow from. So all the extra charges or excess charges which are not required for an appliance or an electric device are sent to the ground directly, as shown in this diagram. It has been connected to a metal rod which is buried inside ground, so all the excess charges directly move to the ground, keeping the device unharmed. So all the extra charges move into this ground where ground can accept all the charges, because this metal rod is being buried inside ground, which acts as a safety feature providing grounding to the whole electric connection.